This lesson is going to cover the tangent ratio and its inverse, and using both of those to find missing side lengths and missing angle measures. So the tangent ratio is a ratio that tells me, hey, if I have an angle measure, a specific angle measure, this is the relationship between these two sides. So the tangent ratio is the relationship between the opposite side over the adjacent side. So when we read this, we read the tangent of theta equals opposite over adjacent. And we abbreviate that with tan, and theta is a O with a line in it, equals opposite over adjacent. And then inverse of tangent, so this is the equation we use to find missing side lengths. The inverse of tangent is angle theta equals the inverse of tangent times opposite over adjacent. So we just say angle theta equals the inverse of tangent times opposite over adjacent. Now, you've got to be able to identify opposite and adjacent, and if you don't identify opposite and adjacent correctly from the very beginning, you're going to get every problem that you do involving tangent wrong from there on out. So this doesn't include the hypotenuse at any point. We use just the opposite side and just the adjacent side. If you want to label the hypotenuse just so you don't accidentally call it opposite or adjacent, you can do that. I'm not going to do that. I'm just going to label opposite and adjacent. So I'm going to take this triangle, and this is my theta angle. I'm standing in this corner. When I'm standing in this corner of my triangle, I know that the side that is farthest away from me, the side that's way far away that I cannot reach out and touch, is the opposite side. And I know that this side next to me that I can reach out and touch is the adjacent side. Now, I know this one is the adjacent side because there's the 90-degree angle. The adjacent side does touch the 90-degree angle. The hypotenuse does not touch the 90-degree angle. So your opposite and adjacent sides should always make that 90-degree angle. Keep that in mind. If you're looking at it and you get turned around, like the triangle changes here. So you have to note where the hypotenuse is. You don't necessarily have to label it, but you need to look at it and go, that one's the hypotenuse, before you start labeling opposite and adjacent. So let's look at this triangle. If we're standing right here, and we know that this is the hypotenuse, we're going to go ahead and identify that that's the hypotenuse, and we're standing in this corner, the side that is right next to us, that's not the hypotenuse, is the adjacent side, and that means the leg that's really far away on the other side of the room is the opposite side. So make a note. You can make an actual note and write down where the hypotenuse is, or just make a mental note of where the hypotenuse is at, and then determine your opposite and adjacent. So in this first triangle, my theta angle was up here in the top corner, adjacent was next to me, opposite was across from me. If I move to the other corner, the things that I call opposite and adjacent are going to change because I moved. This is no longer adjacent to me because I'm standing way over here on the other side of the room in this other corner. So now that makes this the opposite side and this the adjacent side. So pay attention to where angles are at. Just because you've labeled something as opposite and adjacent, if you move to the other angle, to the other corner, your side labels are going to change. They're going to be different now because you moved, and so how you see the triangle has changed. So for tangent, we've got SOHCAHTOA, so, S-O-H, sine, opposite hypotenuse, CA, K-A-H, cosine, adjacent hypotenuse. And then we have TOA, which would stand for tangent is opposite over adjacent. So let's take a minute and let's actually set up some tangent ratios and solve some tangent ratios. So we want to set up the tangent ratio, we want to write that equation, and we want to write its inverse for the indicated angle. So our indicated angle is angle E. We've got the theta symbol already in it to kind of help us out. So standing here, I'm going to look at this triangle and I'm going to go, this is the hypotenuse, so I'm not going to use it. I can even put an X on it. I'm not going to use it. Standing here, The side that's farthest away from me on the opposite side of the room is the opposite side, and the side right next to me is the adjacent side. So I can say the tangent of E equals opposite, because here's my ratio right here, opposite, my opposite side is V, over adjacent, which is W. And then I use this same fraction, this same ratio, to do angle E equals the inverse tangent of V over W. So that's what it looks like if we're just working with variables. Let's throw some numbers in there. I like having numbers. Math is about numbers. So we're looking for angle W. We're going to set up everything based on angle W. We've already got it labeled as our theta angle. Let's make a mental note that this 17-foot side, that's my hypotenuse, so I'm not going to use that. So I can put an X on it. I can just make a mental note, don't use that. From here, this 15-foot side is right next to me, so that makes it my adjacent side. And the 8-foot side is on the other side of the room, so it's my opposite. So I'm going to take my equation, the tangent of theta, and I'm going to say the tangent of W equals opposite, which is 8 feet long, over 15, which is my adjacent side. And then to write my inverse, I'm just going to say angle W equals the inverse tangent of 8 over 15. Don't change those. Don't change the fraction setup when you go from the equation for solving for a side to the inverse. So the next two problems, we want to find the length of the indicated side, and we want to make sure we round it to the nearest tenth. So we're looking for side SU, so I'm going to highlight that in blue. That's what I'm looking for. And then I'm going to highlight the things that I know in yellow. I know the length of this side, and I know this angle measure. So this is my theta angle. I can draw a little theta symbol up in the corner. And we're going to take the setup, tangent of theta equals opposite over adjacent, and we're going to replace the theta symbol and the opposite and the adjacent with what information we have in this triangle. So my theta angle is 54 degrees, so we're going to say the tangent of 54 equals, I need to identify my opposite and my adjacent. I know, mental note, that's my hypotenuse. So that means if this is my hypotenuse, that means this must be my adjacent side. And if this is adjacent and this is hypotenuse, then this has to be opposite. That's the only thing left. So I'm going to do opposite over adjacent. Opposite is 87. And adjacent is the side that I'm looking for. So I'm just going to call it X. So we want to get this X by itself. Right now, this X is dividing. It's doing some division, so we're going to multiply. Because it's doing the division, we're going to multiply by that X. That way these X's cancel out and leave me with X times the tangent of 54 equals 87. And then we want to get X by itself. It's not by itself yet. It's still got a friend stuck to it. We need to get rid of this tangent of 54. So we're going to divide by the tangent of 54 because this was multiplication that was happening. We're going to divide. And we're going to need our calculator for that because our calculator has all the trig ratio tables in it. And we're going to say, not y equals, we're going to say alpha y equals. And we're going to say 87 over the tangent of 54. And we're going to round to the nearest tenth because that's what our directions wanted. So we're going to say 63.2. The length of SU is 63.2. In our second example, number 4 here, we want to find the length of AC. So AC is here. That's the thing we're looking for. What we know is the length of this side and this angle measure. So this is our theta angle. I'm going to put a little theta in the corner. And I'm going to use this same setup. Tangent of theta equals opposite over adjacent. So let's label opposite and adjacent. If I'm standing here in this corner, all the way over here on the other side of the triangle is my opposite. This is not my adjacent. This is the hypotenuse. My adjacent is the other leg. Remember, the opposite and the adjacent are going to make that 90-degree angle. So that's my adjacent. So we're going to go back. We're going to plug this in. We're going to say the tangent of theta. We're going to take the theta symbol out and replace it with a 37 because our theta angle is 37 degrees. And then we're going to take the O out and replace it with what we know about the opposite side. Except the opposite side is the side we're looking for, so we're just going to call it X. And then we know that the adjacent side is 11. So we're going to plug that in. And then we have some division going on here. When we have division, we always multiply by the denominator. And that leaves X by itself. So we can go ahead and we can just type this into our calculator. So it's 11 tangent of 37. And we find that missing side, AC, is 8.3. That's the length. We don't have any of the units of measurement on those. We just know that it's 8.3 something, whatever it is. So we just type this into our calculator. The calculator goes and finds the tangent ratio that goes with 37 degrees and says, well, because the angle is 37 degrees and the adjacent side is 11, that means the opposite side has to be 8.3. Now, sometimes we know all of the side lengths, but we don't know the angle measures, and we want to find out what the angle measure is. So we're going to find the measure of angle A, and we're going to round to the nearest whole degree. So what we're looking for is angle A, which is right here in this corner. And what we know is we know that this side is 84 inches, and this side is 13 inches. So if this is my theta angle, that's my theta angle. This side is my hypotenuse. You can label it if you want to. You don't have to. If this is my hypotenuse and this is my theta angle, then this has to be my adjacent side. And if that's adjacent to hypotenuse, then that has to be opposite because that's the only thing left. So we're going to take the angle A equals the inverse tangent of opposite over adjacent. And we're going to replace this opposite over adjacent. So we're going to say the inverse tangent equals the opposite side is 13, the adjacent side is 84. And then we're just going to type that into our calculator. So tangent, and right above tangent, do this every time. Here's tangent, right above tangent in blue is tangent to the -1 power. So that's the inverse of tangent. So we're going to go second inverse of tangent, and then we're just going to put in the fraction that we wrote down, 13 over 84. Like I said, I've said before, you can use division or you can use the alpha y equals button, either one. And we find that it comes out to 8.79. Well, our directions said to round to the nearest whole number, so that 7 tells me to round that 8 to a 9. So angle A is 9 degrees.